Yes, class. So in the last class, we've completed the parallelogram law, and parallelogram law was done. Just a little bit about the triangle law and polygon law I'll tell you, because magnitude is the same. See, triangle law basically says that if two vectors are in the same order. Now for this, you should understand what is meant by same order and what is meant by opposite order. You are not able to hear me. Am I audible, class? Is it audible?
Yes, ma'am.
Okay. Tahura's internet, it must. Mariam, it's audible to you?
Yes, miss, I can hear.
You can hear. Tahura, just rejoin. Okay, so same order and opposite order we have done. Same order and opposite order. Now, same order means when two vectors, this is the tail, this is the head, coincides with others tail and head. See, this is the tail, this is the head. This is the tail, this is the head. Okay. Now, opposite order means that if they are the head and head is coinciding with them. Okay. If the head and head are coinciding. Let's say if this is the case and this is the case. See, this is the tails, this is the heads, and heads is coinciding with the tails. So if this is the case, then we do not use the triangle law. Triangle law is only valid if the vectors have the same order. Okay. Now, what if the tails and tails coincide? Then we call that condition as coinitial. When the tails and tails coincide, that we call as coinitial. So anyways, if you see two vectors in the same order like this, let's say this is one vector A, this is another vector B, their resultant is given by the closing side of the triangle taken in the opposite order. See, closing side of the triangle and taken in the opposite order. This is the heads with the tails. This is the heads and the heads together. This is what our triangle law is basically. You can take this angle between A and B as theta. So triangle law basically says that if two vectors are representing the adjacent sides of a triangle, in the same order. This is the condition, in the same order. Then their resultant is given by the closing side taken in opposite order. That's it, what you need to remember here, just in case if it comes, for those students who haven't done. Magnitude still remains the same. Same formula. You have the same formula. Under root a square plus b square plus 2ab cos theta. Okay, that's the formula. Same formula for direction also. Tan beta is equal to b sine theta by a plus b cos theta. You're still not able to hear. Mariam and Humaira, I'm audible to both of you, at least.
Yes, ma'am.
Yes,
Can it
miss.
be her issue? She's not able to hear. Why? Okay, so this is the triangle law. So this will be required the least. We'll be requiring it the least. Now, just write this down. Mariam, your notes are already completed. Triangle law and all you have already written.
Yes, Miss, I wrote.
You have already written. All right. So just write it. I'll start with the parallelogram law and all. Not the parallelogram law, sorry. Wi-Fi is perfectly coming. So if you then she must have not entered the audio. All right. Just do one thing, Humaira, copy it down till here. Then let's just complete it so that we can complete motion in a plane, so that we can now start with laws of motion. Just write
Yes.
it.
Ma'am, in chapter 1, units and measurement, we didn't complete the significant figures.
Yeah, for significant figures, I'll share a PDF with you because significant figures is just a theoretical part. Yes, I have the table with me. I just have to discuss it with all of you. I have it typed already. Okay, I've typed it. I'll just share the PDF. So before your test or next week, we'll just discuss. Or tomorrow also we can discuss. Okay.
Okay, ma'am.
First, I'll share the PDF with all of you.
Done, ma'am. No.
Okay, see, this is the triangle law, parallelogram law. So we are done with the polar part. In the Cartesian form, we are done with the unit vectors. Just a bit about the addition and subtraction did we discuss before this? Yes, addition and subtraction also we have discussed. Just dot product and cross product are left. Let me discuss that also. So your vectors will be done and straight away motion in a plane. I'll start with that chapter.
Miss
Okay.
Polygon law?
Oh, yes, 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 Pauline. Thank you, Mariam. Right, right. One more law is there in the polar form, that is the Polygon law. Now, see, class, Polygon law is exactly the same. Again, the magnitude and all is the same. But see, poly means many. The term poly here means many. So, many means many vectors are there. If many vectors are there and they look like a polygon, polygon means various sides are there. So how the resultant will be given? Let's say this is one vector A, this is one vector B, this is one vector C, this is one vector D, this is one vector E. So what you do, Humaira, see, A and B are there. Forget everything is there. Just imagine as if only A and B are present. So this looks like a triangle law. So their resultant can be given by this. That will be your first resultant. Similarly, you use this resultant with the C vector now. And again, apply the triangle law. Like this, you will get another resultant R2. Similarly, here you apply, you get another resultant R3. Finally, R3 with this E, you get your final resultant, that is the R equivalent resultant of all. You use multiple times usage of the triangle. So it is also given by the closing side of the polygon in the same order. It's exactly the same thing. It's just that this is given by the closing side of the polygon. Wherever triangle is there, the term polygon is there. Same magnitude. This is the same formula of the magnitude. Same formula for the direction. Exactly the same. It's just that how will you use it? See, I'm repeating. This is one vector A. This is another vector B. You imagine as if this is a triangle. Triangle law we are applying. Forget rest. So this will make your first resultant. So these both are gone. You have this. Again, like you take theta here. Similarly, you solve it. You get your first resultant here and you don't need AB now. Then take this resultant and take this vector. And as if these two are the vectors right now. Solve them, get one more resultant. Take this resultant with this, get one more resultant. This with this until you finally close the parallelogram. Polygon. Got it, Humera?
Yes, ma'am.
All right. Same formula, same magnitude. Now just dot product and cross product are left. So these could be done later also. But your vectors will be left. Let me complete it itself in today's class only so that your vectors portion is done. See, for dot product, what we do, dot product is the easiest, it will be done. This is used when you have the scalar resultant. If your resultant is a scalar. Okay, when your resultant is a scalar, then we use this. Means two vectors are getting multiplied. Vector 1 getting multiplied to vector 2. But the resultant is a scalar quantity. Then we apply the dot product in that case. Like if I give you one example, in the work energy and power we'll do work done is equal to force dot displacement. Now look, for us we already know force is a vector, displacement is a vector, work done is a scalar quantity. So this is when we use the dot product. Or one more formula in that chapter we'll discuss would be power is equal to force dot velocity. Now here also you can see power is a scalar quantity, force is a vector quantity, and velocity is also a vector quantity. So dot, this is when you apply the dot product. Now how to use it? Very simple. In polar form, I'll tell you, then I'll discuss it in the Cartesian form. In polar form means two vectors are there. Let's say this is vector A. This is vector B making an angle theta. So for the dot product, what do we do? Take the magnitude for A dot B, take the magnitude of A, take the magnitude of B, and multiply it with cos theta. Magnitude of A, magnitude of B multiplied with cos theta. That is what your dot product is equal to. This is basically how you open up the dot product. A dot B is A vector, B vector into cos theta. That's it. Very easy, very simple to solve. Like if I give you one question here, a velocity of 3 meter per second makes 45 degrees with another velocity of 8 meter per second. Calculate the dot product. Yes. So, see here, Mariam, since you already know, you can help me. How to begin with this? V1 is 3 meter per second. V2 is 8 meter per second. Theta is 45 degree. Yes, Mariam, right? Formula, tell me. The net velocity will be equal to dot product of these two. Calculate the dot product, it is saying, no. So V1 dot V2.
Yes,
So
Miss.
it should be written as V1, V2 cos theta. V1 is 3, V2 is 8, cos theta is 1 by root 2. Okay, so answer is 24 by root 2. We can rationalize by multiplying and divided by root 2. That makes it 12 root 2 meter per second. Like this, you have to apply. Got it, both of you? Mariam Umaira.
Yes, ma'am.
Write it here. Some more questions we'll practice. First, write it from here.
Done. Done, ma'am.
Okay, Laura, no problem. Now, if you're done with the exam, so start submitting it so that we can discuss it also. From this batch, Mariam and Nabiha are giving the assignments religiously. Other students also, Tahura, you have told me you will give. Humaira, you also please share your assignments.
Ma'am, I have already shared my assignment on 27th.
Which one, Humaira, you've shared? Okay, yes, Humaira, you have. Look at this question. It says the force applied on an object of mass m is 50 Newton. The object moves by 2 meters. If the applied force was at an angle of 60 degree to the displacement produced, you have to calculate the work done. T, formula of work done is F dot S. Now, Humaira, expand this formula. What have you learned in dot product? How should we write this? What comes next? A dot B is equal to
Cos theta. AB
just
cos theta.
AB cos theta. So this is equal to AB cos theta. So this will also be equal to Fs cos theta. Okay. Now work done is force is 50. Displacement, see it says object moves by 2 meters. Displacement is 2. Cos 60 degree is 1 by 2. So that gives 50 joules of work. Now work done and all, we'll discuss in work, energy and power in detail. But I hope the dot product's usage in polar form is clear.
Yes, ma'am.
Yes, ma'am.
All right. Sana, you joined late. At that time you've joined. That's such an early moment. All right, just completed. Yes, written.
Yes, ma'am.
All right. So this was in polar form. Now, how do we use the dot product in the Cartesian form? Cartesian form, I already discussed with you. That means it is I cap, j cap, k cap. It's written in terms of this. I have given an assignment of unit vectors. That is still not done. Unit vectors assignment is still left. There are good questions in that I have to discuss with you. Class, today please submit your pending assignments. Tomorrow we'll discuss all the assignments. Because from vectors, unit vectors, we didn't discuss any assignment, and parallelogram also. Okay, so vectors I'll be discussing. So whatever pending assignments you have from vectors, attempt those first. So this is the Cartesian form. In Cartesian form, let's say you have a vector. A vector is there, A1 I cap plus A2 j cap plus A3 k cap. Then B vector is there, B1 I cap plus B2 j cap plus B3 k cap. Now, when you calculate the dot product, what you do, you multiply A1 into B1. See, remember, I cap dot I cap or J cap dot J cap or K cap dot K cap. Yes, Mariam, what it is equal to? Do you remember? Mariam?
Yes, Miss.
1. Okay.
Uh,
I cap dot I cap. Reason is that these become the parallel vectors class. Look, these are the parallel vectors. So if two vectors are parallel, I cap dot I cap means something is along x-axis and the other quantity is also along x-axis. So parallel vectors means the angle between them is 0 degree and cos 0 degree is equal to 1. And unit vectors have the magnitude also as 1. So it's ultimately like 1 into 1 into 1, which is equal to 1. Even if we talk about the y-axis one. Yes, Mariam, recalled?
yes, Miss. But I wrote that it's equal to 0 because theta is equal to 0 and sine 0 is 0.
That you have written for cross product. Where do we have sign here? This is cos, na? Dot product has cos in it.
Oh. Yes, Miss.
Okay, that is for this cross product because we have sign there. Okay, here cos 0 is 1. Like j cap dot j cap or k cap dot k cap. So see, in all the cases, you have theta as 0 degree. So see, it's like if I have to calculate the dot product here, I dot I cap. This is I cap cos theta. Magnitude of I cap is 1. Magnitude of I cap is 1. Cos 0 degree is 1. So answer is 1. Similar for all. So what you do when you have the dot products, I dot I will be 1, J dot J will be 1, K cap dot K cap will be 1. So you just multiply these terms and add them. Because the unit vectors you already know. So how can you write? You can say A dot B is equal to, let's say this will be A1 into B1 plus A2 into B2 plus A3 into B3. No need to write I cap, J cap, K cap because their products are already 1. That's it. This is your answer. For example, if I give you, let's say, a force is there 3 I cap plus 2 J cap plus 8 K cap. Second force is there 4 I cap minus J cap minus K cap. And I have to take the dot product of them. F1 dot F2 has to be calculated. This is the question. So see, I cap term and I cap term, just multiply them. F1 dot F2, 3 into 4. That's it. Plus these two terms, the coefficients 2 into minus 1 plus these two terms 8 into minus 1. That's it. So this is equal to 12. This is minus 2. This is minus 8. That's it. Now see, you have a definite number. 12 minus 2 is 10. 10 minus 8 is 2. So resultant is 2 Newton. That's it. Just multiply and add the terms. Am I clear?
Yes, ma'am.
Yes, ma'am.
All right. Tahura, you're understanding? Tahura?
Yes, ma'am.
All right. Please write it till here. One question I'll give you, then we'll move on to the cross product. Resolution of vectors is left. That also we'll have to do. Have you all written? Should I move forward?
Yes, ma'am.
All right. So let me discuss the cross product and then resolution of vectors. So that will complete the vectors. Okay, cross product in polar form, let me discuss first. Now, Mariam, the sine theta will come. So let's say this is one vector A, this is one vector B. So as I was discussing with Mariam, here when you have the cross product A cross B, this is equal to magnitude of A, magnitude of B, and sine theta will be here. Remember one important thing about the cross product, this is anti-commutative. Anti-commutative means you can, if you are writing A cross B, that will not be equal to B cross A. While your dot product is commutative. Commutative, anti-commutative is like addition and subtraction. Addition and multiplication follow commutative property. 5 into 6 is 30. 30 divided by 6 is 5, right? Or we say, let's say 3 plus 2 is 5. So 5 minus 2 will give you 3 back. So you can write it in any way. You can change. Like if I say 3 into 2, so 2 into 3, that gives me the same thing. But if I say 3 divided by 2, that is not 2 divided by 3. So division is anti-commutative. So cross product is also anti-commutative. You can't change the order by yourself. So anyway, sine theta will come. Let's say one example I'll give you. Let me take a basic one. Let's say this is the acceleration, that is 4 meter per second square. Okay. And this is another acceleration acting on the body, that is 2 meter per second square. The angle between them is 30 degrees. So when we take the cross product A1 into A2, that is magnitude of A1, magnitude of A2 into cos theta. Now, if I say acceleration is -2, class, I don't have to put minus sign because formula says magnitude. These are the magnitudes, class A and B. These are the magnitudes in both dot product and cross product. Okay, these both are the magnitudes. So this is 4 into, I'll not take -2. I'll just take 2 into cos 30 degree. That is 4 into 2. Yes, Tahura, what is cos 30? Sine 30. Tell me sine 30. Because sine will come. We are taking the cross product. Yes, Tahura, sine 30. Not cos 30. Tell me sine 30.
Yes, ma'am.
What is sine 30 degree?
Ma'am, why are we taking sine?
In cross product, we take sine. We don't take cos. Okay, this is the cross product. Cross product means when vectors are multiplied to vectors, the resultant is also a vector. In that case, we can't use dot product. We have to use a different method that is known as the cross product. Sine 30 degrees is half Tahura. So 2 will be cancelled and that will be 4 meter per second. Remember here, don't take the negative sign. Magnitude here also, in dot product also, don't take the negative sign. We only take the magnitudes here. Here, if this velocity was negative, see here, these are the magnitudes that we consider. This is the magnitude. Okay. So it is anti-commutative is important. We take sine theta here. And this is one example. Let me give you a question. separation of its blade from the axis is 2 meter. Calculate the torque required to rotate the fan. Now, torque you don't know. Torque is basically a rotating force. This will come in the rotational chapter. I'll tell you its formula right now. Torque, this is how it is represented. Torque is equal to R cross F. So, I have, see, torque is equal to R F sine theta. Now, fan, we already know. When a fan is there, let's say this is the top part of the fan, and this is how the blades are present. So we know the angle that the blades and the axis make is 90 degree. So we'll take the separation is 2, force is 8, and sine 90 degree. Yes, Humaira, what sine 90?
1.
1. Very good. So 2 into 8, that is 16 Newton meter. Now, class, don't worry about what is this formula, what is the meaning of torque. We'll be discussing. Right now, my purpose is to teach you the method. Once you know the method, you will not have to study vectors till your class 12th. Once you are done with these, you are done for your 12th also. That's why it takes time to study all these topics. Okay, now I'll discuss it in Cartesian form. So write it from here. We'll discuss it in the Cartesian form.
Done, ma'am.
So can we move now? Done? If anyone's right, please stop me then. Okay. So Cartesian form, it's different. It's a little different. See, let's say we have one vector A. Or let me give you a proper example only. Let's say I have the force as 3i cap plus j cap plus k cap. And the radius is given as, means the separation is given as 2i cap plus j cap plus 4k cap. All right, so this is what I have. Now, when we take the dot product, cross product, first of all, you have to check where is your R placed and F placed. Like if I have F is equal to R cross, sorry, torque is equal to R cross F. So if I'll have to calculate this R cross F, so I'll have to see whether torque is present first or the radius is present first or the force is present first. So if my radius is present first, what you do, you make a determinant system. Pay attention here because this is completely new. I cap, J cap, K cap. So you make the determinant system. What you do, you fill in the coefficients as it is given. R is first, so we'll write the coefficients of R here. We'll fill them here. This is 2, so we'll write 2 here. J cap's coefficient is 1, so we'll write 1 here. K cap's coefficient is 4, so we'll write a 4 here. Now we'll write the coefficients of force. This is 3, this is 1, this is 1. Now all the coefficients are written. Now see how we have to solve. When you have to write the I cap, so you will write, you strike the column and the row. What is left? These 4 are left. Go diagonally down minus diagonally up. Means 1 multiplied to 4. So 1 into 4 minus 1 into 1. This is I cap. Okay. What you do? You cut I cap completely. Then you go diagonally down minus diagonally up. Now it's the turn of J cap. So for J cap, cut the row and column of J cap also. But for J cap, put a minus sign plus. Okay, then because in J cap, there are changes. So it's better if you put the minus sign, then you can follow as it is. Otherwise, you'll have to change it here. So it's better you just put a negative sign, that won't harm. Now, similarly, here we multiply, we go diagonally down. So this will be 2 into 1 minus, then 3 into 4. This is what? This is the J cap. Okay, this into this minus this into this. Then finally, for K cap, you can just write plus. You cut the row and the column of the K cap. Then this into this. So you write 2 into 1 minus this into this. 3 into 1. That's it. This is the K cap. So this whole equation you should be able to write. This is a long. First tell me till here. If it's clear, then only I'll move further.
Ma'am, can you explain for J cap?
For J cap, I'll explain. See, J cap also cut this, cut this. See, you are left with 4 quantities. These two, multiply these two first. We always go like this, diagonally down, then diagonally up. So here also see diagonally down, diagonally up. Here also when we had these 4, we had diagonally down minus diagonally up, right? So you go diagonal. In fact, I have written it opposite here. 1 into 1. Oh, I've just wait. I think I've written it. See, diagonally down 1 into 1 minus 1 into 4. So this is how you go. Now, when you have J cap, you cut this, and just put a negative sign here. Like we put a plus sign here, you put a negative sign. then 2 into 1 minus 3 into 4, whatever is left, because this was already cut. So this into this into, okay?
Okay, ma'am.
To others, is it clear, Sana? Did you get it? How to write this equation?
Yes, ma'am.
Okay. Tahura, Humaira, you have already asked. Tahura, what about you?
Yes, ma'am.
Okay. Mariam, you fine?
Yes, miss. Yes, miss.
All right. Okay. Class, if you write this equation, then there's nothing for you. It's just addition and subtraction, which you already know. You can write 1 into 1 is 1, 1 into 4 is 4. So 1 minus 4, I cap. 2 into 1, 2. 3 into 4, 12, minus 12, j cap. 2 into 1, 2, minus 3 into 1, 3, plus k cap. So what do we get? Minus 3 I cap, 2 minus 12 is minus 10. Minus 10 minus becomes plus. So plus 10 j cap. 2 minus 3 is minus 1. So minus k cap. This is the resultant. Now, if you want to calculate its magnitude, if you further want to calculate its magnitude, we've earlier only studied. For its magnitude, you write under root of minus 3 whole square plus 10 square plus minus 1 square. This I've already told you earlier also. That whenever you have the magnitude writing in Cartesian form, when we did the unit vectors, that time I told you. So this can then be written as 9 plus 100 plus 1, which is equal to under root 110 Newton meter. This is the torque, which we were calculating the torque actually. So this is how it will be done. If magnitude is asked, this step is just one ahead, which we have already done. So this is how we write the cross product. Am I clear?
Yes, ma'am.
All right, please write it. Please let me know done if completed.
Yes, ma'am.
Done? Okay.
Yes, ma'am.
Just the last topic, resolution of vectors. Okay, so vectors will be over. And tomorrow I'll complete the chapter motion in a plane. Motion in a plane is a very short chapter once vectors is done. This is actually a part of motion in a plane only. This is very important. So that's why this has to be dealt in detail. This couldn't be skipped. This will be used throughout your 11th and 12th physics. It's very important. Make your vectors very strong. Do the assignments. I'll share assignments today. So coming to resolution of vectors. Class, for more questions, I'll share some videos also. So watch them too. Just skip it. Don't see the theory part that we've already done. For the questions, just forward and practice few more questions from there as well. Because in video, the advantage is that after the question, the solution is there. I'll be teaching the solution also. In assignments, you just have the question. So we'll share the playlist of vectors from last year. From the revision series, there are lots of questions were done. After your syllabus is completed, we have revision series here. So in the revision series that we'll share with you, so just watch it, just forward, skip the theory part. If there's any trouble with the theory, watch that. Increase the speed forward. It's YouTube lecture only. But to solve the questions properly, first pause the video, solve the question, see the solution. Okay?
Okay, ma'am.
Yes, that's all right. So see, resolution of vectors basically means, let's say I have a main vector. Let's say this is some vector V. Now it's splitting our main vector into its various components. Let's say it is its component 1, this is its component 2. Means when I add V1 plus V2 vectorically, I should get my vector V back. So here in this case, these become the components. Components of the main vector. Now, you don't have to study any sorts of random components. You just have rectangular components to be studied. Now, what is meant by rectangular component? Rectangular components means that the components will be perpendicular to each other. Will be perpendicular to each other. Okay, so components will be perpendicular to each other. Like if this was my main vector, the way I was telling you, let's say this is the main vector V. So the components will be, this will be V1, this will be V2. So V1 and V2 will be 90 degree to each other. So resolution of vector means you have the main vector, you are trying to get its various component V1 and V2. Okay, so how do we do that, class? Let's say we have a main vector. This is some vector A. And we have to find its component, let's say along here, along here. And this is the angle theta that is formed. Now remember the rule. The axis which has theta adjacent whichever axis has theta adjacent, that axis will receive the cos component. Okay, this will receive the cos component. And the non-adjacent one, non-adjacent means the perpendicular one. The other perpendicular one will receive sine component. This is the rule. That's it. Resolution of vectors are the easiest but the important. So see, let's say I have to resolve this vector. So two components will be there. Rectangular components. One will be this other will be this. So how do I decide which one will receive cos, which one will receive sine? So look, the theta is adjacent. Let's say this is x-axis, this is y. So theta is adjacent to this x-axis. So x-axis will become a cos theta, while this y will become a sine theta. What if I change the angle? Let's say this is the vector a, and this is our y component, and theta is made here. See, this is your x, this is your y. So this is a, this is another vector, right? Now, see, now theta is adjacent to y. So don't remember cos theta is always along x or this. Don't remember like that. Remember adjacent is this. This will receive cos theta, a cos theta. This will become a sine theta. This is how you have to resolve the vectors. Am I clear to everybody?
Yes, ma'am.
So, Sana, you have not understood anything?
Yes, ma'am, understood.
Understood? So, please respond. Tahura, what about you? See, this chapter vectors was already completed in this batch. Many other students have done it. Since you all have joined recently, that's why this chapter was done again in the same batch, because your timings weren't coinciding. So especially the students who are new, pay attention. You don't have the notes and all written. Mariam already has her notes written. That's why I'm not asking her. So when I ask, please at least respond. So I know you people are getting. And if there's any doubt, even a single query you have, and it's a silly query, just get it clarified in the class itself. Okay? All right, copy this from here. Till here you've written. Write it. Just written.
One minute.
Okay, just completed. So I'll stop here. In the next class tomorrow, we'll continue motion in a plane and we'll complete that. So from the next week, we can start with laws of motion then. All right.